We talked about machine learning concepts, types,
Yep.
and all.
Yep. So the life science, the project life cycle of data science, and
Yeah.
for solving any kind of data science problem, then we would like to go for using the machine learning and deep learning, right? And for that one, what type of machine learning algorithms are there in industries? That's what we had in the discussion, right? Right, Arun?
Yes.
Okay, so now we'll talk about machine learning introduction. Okay, so you already know that what exactly the machine learning. I already shared with that information. So the machine or software, it can be learned itself without any explicit program. Okay, so the difference between machine learning algorithm and machine learning program and the traditional program also we already seen that, right? And so there we have a different type of machine learning algorithms are there in the market and in industry. It could be like, supervised machine learning algorithm. And second one is it could be like, unsupervised machine learning algorithm. And third one is it could be like, reinforcement, right? So you can say that it could be semi-structured, reinforcement, reinforcement machine learning algorithm or semi-supervised machine learning, anything you can say. Okay. So, yeah. So coming to that supervisor machine learning algorithm, there it could be like, you have a data. The data, it could be having some kind of we have some kind of input as well as we have some kind of output. Okay. But here we have a data, but with help of that data, we have to make it some kind of segmentations, clustering. But there we don't have any kind of output variable. Okay. But when coming to that reinforcement, when you don't have a data, that situation, we can choose this specific machine learning algorithms, right? So, and coming to that, based upon output variable type, so we have again two type of machine learning algorithms. It can be work and it could be like, regression, and second one is the classification, right? And coming to that, regression. So here the output variable is numbered data, then you can choose the regression type of machine learning algorithm. And if output variable is category, category, categories, categorical type, then we can use the categorical type, then we can choose the classification actually. So there we have a two type of classifications. One, it could be the binary classification. Okay. One, it could be the binary classification, and so second one is that, multi-classification. Binary classification in the sense the categorical variable, we have yes or no options. And multi-classification in the sense the output variable, it might have more than, it might have no more classes. I just give you some real-time use cases so that you can easily understood at what situation, and based upon the problem statement, you can easily we can easily finalize that which type of machine learning algorithm should I use it. Okay. So here I have a problem statement is, okay, I would like to go for predicting the I would like to go for predicting the airlines ticket price. So for example, there it could be different kind of airlines, right? Like, Indigo or else, American Airlines, different kind of airlines, right? So for example, I would like to go for predicting the airline price, airline ticket price, airline ticket price. Okay. So ticket price means it could be like, number or not. So airline ticket price in the sense you might have some kind of data, something like this. And this is my price variable. And airline name and arrival and departure, arrival and departure. Okay. So this is the data you can maintain. And coming to that area of price, it could be like, $500 or else $600, something like this. Okay. So here, this I would like to go for predicting the I would like to go for predicting the, okay. So airlines ticket price, right? This is my no, historical data. So with help of historical data, we can choose one type of no, machine learning algorithm, and we can able to build the model. That is different story, right? So which type of machine learning algorithm should I select for solving this kind of problem? That situation here, I have a data which is having input variables. These are all input variables, and this is my output variable. So here my output variable, the data type is here, it's a number data. Then that situation, we can choose the regression. Did you got my point? Did you got my point or not? So here the price variable, it could be like, number format. When output variable, which is a number format, then we can choose the regression type of machine learning algorithm. Okay. Now, I would like to go with some another use case, like predict whether the ticket price can increase or not. Okay. The ticket price is high or low or medium. Okay. Predict same problem statement, but in a different use case I'm giving. Okay. Predict airline ticket price, high or low or medium. Here, how many options we have it? How many options we have it?
Three options.
Three options, right? There it could be like, three different categories. So here I have maybe I have a client, I'm working for one particular client. The client is given the data something like this. Okay. So your airline name and arrival and departure and data for journey. And so here the price type. Okay. So here we have something like high, and here we have something like low, and here we have something like medium. So here my price variable, here my price variable, okay, which is categorical data or not. When my output variable, which is in a categorical type, then I have to choose the classification machine learning algorithm. Okay. Classification machine learning algorithm. Any questions till now? Okay. Now I would like to go with one more problem statement. Okay. So one more problem statement. So you have to choose that particular problem statement, and you have to be okay, fine. So you have to choose, and I'm just giving a small problem statement actually. Okay. Like mm, customer segmentation. Okay. Like you're working for one particular company, it's a Walmart company or something else. So I have a data. I don't have any kind of variable actually. Okay. So I don't have any kind of specific output variable. Okay. I have a customer data, like, okay, so the customer ID and the customer name, and so city and age and everything. Okay. So when we have a data something like this, and so from this all, you might have similar properties, right? So from this particular similar properties, we have to make it some kind of cluster, group of cluster, maybe from this all features, this category people are one group. Okay, they might be interested this kind of products, and with this type of features, it could be like one group. Okay, that way you can able to category, that way you can able to cluster it, make it some kind of group. That kind of situation, we can choose the unsupervised machine learning algorithm. So the example for unsupervised machine learning algorithms are, it could be like um, what we call clusters, DB scan, k-means clustering, hierarchical clustering, different kind of things. We can choose it. Okay. And I'm not giving any kind of data, something like self-driving car, or so when you're building self-driving car, okay, so driverless car, self-driving car, whatever it is, okay, so you don't have any kind of data, right? So by the time of starting of implementing of that project, then it was generating the data, and based upon that performance, and they will be give some kind of feedback system. Like if it is correct, then it could be the positive feedback. If you're getting wrong prediction, then you will be getting like negative record. That way you can work reinforcement. And I'm not talking about reinforcement at this moment, and that is not needed at this moment actually. So mainly we are going to be concentrating on the supervised and unsupervised only. So in a real time, I mean in a data science field, mostly the problem statements are comes supervised and unsupervised. Of course we have some other algorithms like reinforcement. When mostly artificial intelligence comes to the picture, then reinforcement will when so we would like to go for use that kind of algorithms actually. Okay, clear, right? Okay, now so now okay, now first we'll start with regression. Okay, from the what we call from regression, from supervised, first we can try to go for understanding the regression. Okay, so at what situation the regression problem statement we could use it, that you already understood. When my output variable, or else the same thing we can call it as the labeled data. Okay, so you can call it as the output variable, or else labeled data, or else a response variable. Okay, so response variable, this all it could be like in the same name only. Okay, so it could be like a number. Then that situation we can use the regression based machine learning algorithm. I hope you got that point, right? Okay, now coming to that regression, very basic and very sim and very very basic regression is simple linear regression. Simple linear regression. Okay, second one is multiple linear regression. Okay, and third one is lasso regression, and the fourth one is ridge regression. Okay, and next one is polynomial linear regression, random forest linear regression, and decision tree regression. So various regression concepts we have it: random forest regression, and decision tree regression. Okay, and polynomial linear regression. So different type of machine learning algorithms are there. So this all type of machine learning algorithms, and we can try to go for understand one after one. And if you have any kind of specific questions, please let me know so far. Any questions? Okay. I just give some kind of example for understanding of simple linear regression. Okay. So, so I'm just giving a data set, something like this. And simple linear regression in the sense, you have only one input variable and one output variable. That's it. That situation, and we can choose the simple linear regression. I have only one input variable and I have only one output variable. Okay. For example, based upon the age, or else based upon the age, I would like to go for finding the weight. Okay. So something like this, or else yeah, anything. It's when we have only one input variable and when only one output variable, that situation we can choose the simple linear regression. For example, here my x is 5 and 6 and 7 and 8. And coming to that, my y variable, it could be, for example, 10. Okay. This, it was, for example, 12, and it was 15, and it was 20, something like this, or else 17, something like this. Okay. See, here we have a data is one x variable, and here I have a data is one y variable. Okay, we have only one thing. So now what you have to do, actually, you have to find the relationship between these two things. Let me take it, this is my x variable and this is my y variable. Okay, so here I have the some data points, right? Okay, so here I have the y data points, right? Okay, so corresponding 5, there could be like, this is 1 point. 10 corresponding 6, my y value, for example, it could be, for example, 12. And so it, for example, it was 15, and it was, for example, 17. Okay, see, something like this I have it. So when data points are something like this, actually in real time it was not 4 points. Actually, there could be something, when you plot scatter plot, you will be getting the dot something like this. Okay, you will be getting the data points in the 2D plane. Okay, now what we have to do, actually, we have to find the relationship between x and y. Okay, we have to find the linear line. So for example, if you draw the line, so it will be go something like this, right? So I have to find this best fitted line. This is my regression line. So this regression line, usually we can represent it with y equal to mx plus c, right? So here m is my slope and c is my constant. M is my slope and C is my constant. So we have to go for finding this M value, and we have to go for finding the C value. If you know the M value and C value, X is your input, right? Then you can easily predicting the Y or not. For example, let me take it. I'm just finding that, how we are finding M value and C value, that I can discuss later. But let me take it. Let me consider Y value, sorry, M value, for example, it could be like a 2. C value, for example, it was 1. Just imagine. Okay. Or else it was 0. Okay. It was 0. Then in my new input, for example, my x value is the 10. Then I want to find this value, right? So you already know that formula, y equal to mx, please. M value is 2. 2 into 10, it's a 20. And plus c value is how much? It's a 0, right? So 0 plus 20, it's a 20. So that this way you can able to find some new points for test values, or else for any future things. That way you can able to predict. So when I see this particular graph, and what exactly observe, so that means when I have x and y, if you are plotted, if you find if the relationship is the linear, then I have to find the linear line, the regression line. For finding that particular regression line, we have a formula y equal to mx plus c. There m and c are the coefficients. That coefficients we have to find it. That coefficients we have to go for find out. So the best value of the m, the best value of the c, if we know it, then we can easily find the predicted. We can easily find the any future points. So far, is there any question?
No, sir.
Any questions?
No, sir.
No. Are you following or not?
Yes, sir.
Yeah, yeah, no question still now.
Yeah, if you have any small question, you can stop me and you can ask me. That's a very basic things I'm dealing now.
Sure.
So as a machine learning engineer, so you have to go for finding the M value and C value, the best M value, the best C value. That is our aim, right? Clear? Okay. And I just want to tell you one more thing. For example, it is the simple linear regression, so you can easily find. And you know that already we have some kind of mathematical formulas, or else we have already some kind of statistical formula for finding them value and C value. Okay. Let me consider. I have the multiple linear regression. So when we can use the multiple linear regression? So I have the multiple inputs. I have the multiple inputs. Say, for example, here it is my x1, and this is my x2, and this is my x3, and this is my x4. And even usually, generally, I'm telling that it's x1, x2, x3, x4, but in real time, something names are there, like date or height or airline or else date of joining. So something like this. There could be some kind of column names, and x5, and this is x6, and for example, this is y, right? So here, this y, it may depending, this y value, which is depending on the x6, and it was depending on the x5 and x4 as well as x3, and it was depending on the all the inputs. Okay, so the y, which is depending on this all inputs, that particular situation, okay, so we can able to go for using the multiple linear regression. So that means here my y is a number, and which is depending on the multiple inputs, then I can choose the multiple linear regression. Okay, which is not possible show you in a 2D dimension because of here we have a multiple variables. So I cannot show you the graph actually, but so I just tell you the formula. Okay, for example, this is my y predicted value, and every input, it might having some kind of corresponding coefficient is there, plus m1 plus x1 and m2 plus x2 and plus m3 plus x3, okay, plus m4 plus x4 and so on. How many variables we have it, that all things, each and everything, it might have some kind of corresponding coefficient. And finally we have the c. Okay, is it clear? So this all m's and everything, then you can take it like so you can represent it with something like m underscore x power of t something or something, we have it that I'm not remember exactly the formula. Okay, but usually y equal to m1 plus x1 plus m2 plus m2 into x2 plus m3 into x3 and so on, you might have it, right? So here we have to go for finding the this m value, m1 value, m2 value, m3 value and so on, the c values. Okay, so here also we have to go for finding the coefficients, and here also we have to go for finding the coefficients. Even it is the simple linear regression or multiple linear regression, the way of approach, it could be simple, is the same. Clear? So guys, if you get these points, then it's a very simple, so that I can show you some documents so that you can easily understand. Okay, let me go for open the document is. Okay, so let's see this particular document and you will get some idea. Okay, the mathematics behind the linear regression is based upon the concept of finding the best fit line, and it was y equal to mx plus. So there I mentioned like mx plus c, but here it is mentioned like mx plus b. It's just a names, right? Okay, so where y is the dependent variable and x is y is the dependent variable, x is the independent variables. So there I mentioned like, y is the output variable and x is the input variable. So different names, it's different names. So m is the slope and y is the intercept value. So our aim is that we have to go for finding this m value and b value. Okay. So in linear regression, we have to find the values of m and b. So how we can able to find for minimizing the difference between, see, I just show you how we can able to find that one. I'm just show you here example. For example, this is my x and my y variables. Okay. So, and what I can do, I have some value, something like this 5 and it's a 10 and 6, it's a 12, something like this. Okay. And you find that, so, what we can do, we have to find that some linear line, right? So here y hat. So here we are getting that, 10 or 15, or here it is 20. So there could be some kind of difference, right? Y hat, this is your predicted value, this is your actual value. Okay. So once if you are finding the linear regression, and if you pass the m value and c value, you will be getting some kind of things, right? So this value and this value, the difference, we are calling it say error. Okay. So your predicted value, and that means your estimation value, and your your actual value, the difference, we are calling it say error. That we can call it as the loss. Okay. So, to minimizing the difference between the predicted values and the actual values of the data. So our aim is that why we are finding the best fit values, y, m, and b. So when you find the best values of m and b, so your loss, you're minimizing your error. It could be very, very small. Okay. If you're finding the wrong values of m and b, so the error, it could be like maximum. So if you find the m and b, so that we can able to minimizing the difference between the actual and actual and predicted value. Okay. This difference is measuring using various loss functions. Like mostly we are going to be using the mean square error. So I can show you, I can tell you what are the loss functions we have it. But so basically the difference between actual and predicted value, that we are calling it's a loss. Okay. So we have various loss functions are there, that all loss functions we will discuss in a further sessions. And for to determining the best fit line, that means this red color line, to determining this best fit line, so we use the method. The name of the method is least square method. Okay. So that method we are calling it's a least square method. This method is minimizing the sum of squares of difference. That means y hat, y minus y hat, the up, the top symbol we are calling it's a y hat. Okay. The difference between the y and y I and y hat high, that we are calling it's error. So, the method is minimizing the sum of squares. So you can square and we can do the sum for each and every variable. Then that value we can, this method is minimizing this. You can minimize that particular difference actually. Square, we can do the square and then we can do the sum. So that way, that value that we can do the minimizing. Okay. The value of m and b, it minimizing the sum of the values of the best fit data. This equation is calculated the slope and the intercept values. So here we have some line, right? So there we can find the mn value, and then we can find the some difference between observed and predicted value. If it is the distance is very high, that means your loss is very high. Okay. Where n is nothing but it's a number of inputs. See, for example, here, how many here, how many points we are considering? Let me take this example. There are how many rows we are, how many observations we are taken? 5, 6, 7, 8, right? There are 4 observations you taken, that we are saying that it's a number n. Okay, number of observations, where n is nothing but number of data points, and x and y are the independent and dependent variable. So this, the summation in overall data points. For example, you can see that number of hours of study and your exam score. For example, you have an exam and you're studying for getting good score, and daily you're studying only 5 hours, then you're getting the 80 score. When you're studying 7 hours, then you're getting the 90 score. And you're studying 3 hours, we're getting the 70 score only. When you're studying 8 hours, then you're getting the 95 marks actually. So based upon this number of study, then we have to go for predicting that, your exam score. For that one, we are taking this default data or else historical data. Okay. For that one, we can calculate it, the m value and c value. So how we can calculate it, m value and c value? For that one, we can this equation, this formula, we have it, m equal to n sum of x into y minus sum of y into sum of x by n into sum of x square minus sum of x whole square. So with help of this formula, we can calculate the m, and with help of this formula, we can calculate the b value. If we have a m value and b value, then we can substitute it and we can find the equation line. So this is the equation which is talking about this red line. Okay, clear? Clear or not? So meanwhile, when you are considering the multiple linear regression, we have multiple input variables, multiple independent variables, but we have only one dependent variable. So every independent variable, it might having the corresponding coefficients. So our aim is that we have to go for finding the coefficient values as well as some constant value also. Here also, when you finding the best values, then we can minimizing the loss. Okay. So what are the loss functions we have it? Mean square error, root mean square error, and mean absolute error, different different matrices we have it. And this is the value of the b. Okay, so yeah, x transpose into x inverse into x transpose into y. This is matrix equation. Okay, this is matrix equation. Clear, right? So let me take it. I would like to go for finding the house price. Then we have size of the house and number of bedrooms and the location. And based upon this one, I would like to go for finding the house of the price. Okay. So that is the one use case. And there we have to taking your x value and you're taking the y value. So from this one, we have to do it x transpose and x, and then we can do that inverse x transpose into x, and you can do it inverse, and then x transpose and your y value. This way you can able to calculating the your b value. So b value is not a single b value. B is nothing but b0, b1, b2, b3, b4, b5, b6, something like that. Okay, clear? So if you have that, b values and c values, then you can easily find the best fit lines. So those are the mathematical equations. And you can consider the any linear regression. These are the assumptions we have to follow it. Linearity. Linearity in the sense, you can see your x value and your dependent variable and independent variable, both are linearly correlated. So that is, we are calling it assumption. So if your x value and the y value which is not in a linear relationship, then this method which won't work. So how can you deciding that your machine learning model can be work for that particular problem statement or not? First, we have to do some kind of analysis, and by the time of analysis, we can plot it, and we can plot x value and y value with your input and output variable. So if it is having the linear relationship, the scatter plot which we have the linear relationship, then we can this assumption can be passed. So these all assumptions should be passed, then only we can apply the linear regression or multiple linear regression. Independentness in the sense, one input variable observations are independent to each other. So that means if we have duplicate values, or else one independent variable or else one observation which is depending on the another observation, then which is not independentness. Okay, so make sure that the observations are independent of each and one. This assumption we can check with help of the scatter plot of the residuals against the time of the variable, that may indicating the trend, and usually inspect that is there any pattern is following or not. Or else we have the Durbin-Watson test is there. So if this test, with help of this test, you can finding the independence or not. And so here we have the VLSA method. With help of the VLSA method, we can find the correlation also. Okay. And homoscedasticity in the sense, here we have here we are having some kind of input and output, and actual and predicted, right? Here we have actual and predicted, right? So when you plot the difference between residual error, loss, it could be the same. Okay, so the variance also, it could be the same. Variance of the error is constant. That means if your the constant, the difference between the actual and predicted, it could be constant. It could be maintained some constant. It could not be like, huge variation. Normality. So the residuals, if you plotted in histogram, it will be creating some kind of normality distribution. Okay. What is normality? What is multicollinearity? That everything we'll discuss in a while implementing time that I can show you. Okay. So these are the assumptions. And so with help of the R square, adjusted R square, and mean square error, root mean square error, with help of this mean absolute error, predictive power, and AAC, BAC values, with help of this one, we can finalizing or we can evaluating your model is good or bad. Okay, your model is fitted good or not. That we can easily identify. So your R square, which is indicating that it's a coefficient of determination. It will help you, it is a portion of variance in the dependent variable and explained by the independent variable. And basically this R square, it could be 0 to 1. 0 indicating that the model is perfectly fit and fit with the data, and 0 indicating that the model is not fit well. Okay, so that is the way you can say that it R square. But when your output variable, which is depending on the multiple independent variables, right, might be some of the features are not important. Because of that one also, our R square can be increases. So with help of the adjust R square, even you're increasing the number of features, the R square is increasing, but adjust R square is not increasing. That means the what features we're adding, that is not much impact for us actually. Okay, that is exactly our adjust R square is telling. Okay, adjust R square is modified version of the R square that adjusting the number of independent variables in the model. Okay, it is better to measure the model performance when comparing the model with the different independent variables. So if you're increasing the independent variables and your adjust R square is not it is not increasing, and then that means the model, the feature variable which is not impacting on your dependent variable. Okay, so mean square error, the difference between the actual and predicted, and then we can do that average, that we are calling it, say, mean square error. Root mean square in the sense we just apply the root square for that particular mean square error. And mean absolute in the sense we can find that absolute error, so that here we are not getting any kind of negative value. So the difference, if your magnitude, if you apply the absolute, then you will be getting the positive value. So if you sum of all the positive values, then we can do that mean, then that value we are calling it's a mean absolute value. Okay, and so predictive power and AC, BYC values, so Akai information and BAC Bayesian information, these values, it should be less, then your model is fit. Okay, better fit. If it is very high, then your model is not fit. Okay, so like this, we have some kind of evaluation matrices are there. With help of this evaluation matrices, we can evaluate your machine learning model, your linear regression is working, or whether it is fit or not, whether it is model is best fit model or not, that we can evaluate it with help of this matrices. Okay, see guys, today I just explained you only theoretical part. I can share with you this document and read carefully and try to observe each and every point whatever I explain. Okay, tomorrow what I can do, I can take it some kind of use case and will implement it with help of the Python programming language. Here we'll see the end-to-end project. Any questions? Bruno and Amir, Rahul, Srija, Ramu, and Varun, is there any questions?
No, sir.
No,
No,
sir.
we're good.
Good, right? So I would like to
Yes.
give you this document also, and you just go and Bruno, can you please share me your mail ID so that I can able to give you access for this recordings? Bruno, can you please share me your mail ID? document. Okay. And meanwhile, recording also I can upload and we can access through your mail ID. I mean, we can open that playlist actually. So I am adding that your mail ID. So you will get the notification from, what is the meeting ID passcode? Why you are asking the meeting ID passcode? Don't need. So you will get directly mail from the Canvas and you can access, you can set your own password and you can remember that one and you will able to access Ramu and Sri and Venkat, Rahul, you are accessing, you accessed, right?
Yes,
Are
sir.
you able to access the recordings?
Yes, sir. Yes, sir.
You can able to look, right?
Yes, sir.
But Ramu and Srija, you guys are not accepted the invitation. Please check your mail IDs.
Yes.
So before checking, let me give an permission to share screen so that I can tell you if someone is not having that knowledge accessing the recordings. So it could be easy for us. Okay, so instead of giving that in multiple times. Yep. So Srija, can you please share me your screen? I can tell you how we can access the recordings to everyone.
Yeah. Just give me a minute. I actually logged into my phone. I'll on my
Yeah,
laptop and
who log in from the laptop? Ram,
yeah.
have you logged in from the laptop or not? Yeah, Srija, can you please log in from the laptop? Ramu, can you hear me or
Uh,
not?
uh, just give me a minute. I'm
Yes, sure. Bruno, have you received any mail from the Canvas? So can you please share me your screen, Ramu, so that I can access your recording and I can access your laptop and I can show you how we can access the recordings. So now you're the host so that you can share your screen. Share me your screen, Ramu. Ramu, can you please share me your screen?
I
Okay. So Srija, okay, fine. Srija, I'm giving access for you like a co-host. Can you please share me your screen?
Can you hear me?
Yes, I can.
Hello.
I can hear you. Can you please share me your screen?
Hello.
Srija, I can hear you. Can you please share me your screen?
Yes.
Okay. You set your password. Okay. So that's what I want to show you. Yeah. So if you able to create your own password for the Canvas account and you can bookmark this link and every time you will able to access the recordings and from this particular playlist only. Okay. You don't need to wait for links and everything. So you just open it and you can see that the recordings and everything. Can you go to your machine learning for No, in the top, scroll
Yeah,
down.
I'm good.
Yes, here we have it.
This is the linear
Yeah,
regression
this
document.
is document, what I explain you here. So the document here it is. Okay. Clear? And even recordings also you will able to access it for there itself. That is a life cycle, yesterday document. And that it could be the recording. Clear, right? So that's for today's session, guys. Hopefully you got everything. So let's meet by tomorrow's session. Bye. Take care. See you.